Now, good afternoon. First of all, I want to say how thrilled I am to conclude this part with after the three great speakers and then provoke a bit of a discussion for our panel that comes next. But as said, I'm a growth and innovations manager in Sulapac, which means my job is to do everything new, which is quite exciting, and I'm going to present you two new things from the past year that we've done, and also answer a few of the questions that raised up before. But first, the problem, why do we exist? Why does Sulapac exist? Is that we all know the consumption of oil, we all know the plastic waste problems. Those are two separate problems that are hugely affecting our society and our globe. And especially on the right side, the microplastic problem, it's not in the oceans or in the environment, the full pieces of plastic, the full products that are made from plastics, maybe not the real problem, but the microplastic sludge that is everywhere. Every time you use anything, you use anything made of plastic, you introduce new microplastics in the environment. And based on the WWF study, you eat 1 credit card worth of microplastics every week. So if you think about your own credit card and thinking that somebody would make you to eat one of those every week, if you have a metal one, you've done something right and don't eat that one, but from the plastic ones. And they have been finding microplastics already from the human placenta, breast milk, our brains, our blood, which sounds fairly scary to me. I think hopefully most of you know what this chart is. It's how to divide different types of plastic. As Andre asked from Maija, the bio-based plastic, are they recyclable? Well, especially if we're in this side of the chart, we have the exact same polyethylene molecule in bio-based and in oil-based variations. So the material itself doesn't differ at all, depending on where it comes from. Is it bio-based or fossil-based? On that side of the chart. Then the other side of the chart is biodegradable ones. We can debate what is biodegradable, what is not, how long it needs to take that we can define it biodegradable, but for the sake of this chart, it has a potential to biodegrade, at least. You can also derive those from fossil-based sources or from bio-based sources. Then the question of recyclability of those is maybe more interesting in this side, which I'm gonna come later. But Jukka made me promise to spare the details, so I tried to make it a bit more simple that we all that are not polymer chemists can also understand it. So on the bottom part of the chart, we use oil. It's fossil-based. It's about the raw material what we use. On the top part, materials are bio-based. It's about what do we use to produce something. But then when we go with the vertical line, then we are thinking about what happens to material after it's used. What happens to the microscopic particles that are taken away, wear and tear out of the product, where we have the degradable ones and non-degradable ones, which again, it doesn't matter, do you take it from the fossil-based sources or from the bio-based sources. As a company, we try to position ourselves as far right and as high up in this chart as possible. With the vertical line of degradable and non-degradable, we are not making any compromises. All of our materials are 100% on the right side of the chart. With the horizontal line, is it bio-based or fossil-based? On some cases, we need to still make compromises on the fossil and bio-based sources, mainly based on economics, because bio-based stuff is usually more expensive, and I think it's better option to sell something which is 80% bio-based and to be able to sell it, then double the price and not sell at all, even if it's 100% bio-based. Then the question of recycling. Especially in the beginning of PPWR, the preparation, the idea was that yes, we can mechanically recycle our way out of microplastic problem. Well, it's not the case. We collected around 40%, and out of that 40%, there's 10 to 15% of those materials are actually recycled after the collection. Because it's multi-layer material, it's dirty materials, black materials are fairly hard to recycle, and the prognosis for 2050 is that 37% of those would be recycled. And still, there's the problem when you use, example, the credit card, you swipe it, there's always some microplastics coming out of the material while you use it. So that's not going to be the only solution. Then about Andre's question about the recyclability of biodegradable materials, not only bio-based but biodegradable materials. In PPWR, there is in the table 1 Annex 2 defines a recyclability of biodegradable materials. I think the sentence goes that compostable and biodegradable materials not intended for composting, which basically means chemical recycling. Chemical recycling in this for polyesters effectively is hydrolysis or alkalysis or maybe solvolysis, which, as we can see, you can do it in 100 degrees, 120 degrees or something like this, compared to pyrolysis, which you do for conventional plastics, which needs 1,000 degrees, 1,500 degrees or something. There's quite a huge gap in energy efficiency. And then again, if we have a yield of 95% compared to 30 to 80%, that's also a quite large gap. So to simplify it with a complicated slide, we do a synthesis for biodegradable material. Then, when it wears and tears, we use the material. There's some microplastics going for in the nature, with wastewater, everything. It degrades by biodegradation. Then, when we collect and chemical recycle it, the reaction of the recycling is exactly the same as in biodegradation. It starts with the chemical hydrolysis, maybe enzymatic induced hydrolysis, something like this, but we break the ester bond, which is exactly the same thing that we do in chemical recycling. Also, what's the benefit when we chemically recycle it that way? We bring it back to the monomer stage, where we need to synthesize a new polymer. And then, from the food contact perspective example, we can keep all the food contact approvals and stuff like this, because from that perspective, it's a virgin material, but still it's made from recycled materials. So yes, PPWR also recognizes the recyclability of biodegradables. And this is not just something that looks good on paper. There's already at least 2, maybe 3 factories in the world doing this commercially. And I think the first one in Europe is going to be ready, I think, the summer of 2026. So it's already coming in place, and I think we have still 10 years to go before the restrictions from the PPWR comes in force. But then, as I promised to show you 2 new things and also provoke the discussion. So this is what we started. I have a fairly educated audience, so I think we all played at some point beer pong to these cups, or at least seen some college movies from the States. Of course, the first option, move the paper. Why we started thinking this, and don't quote me on that, I'm not sure that it's true, but that was told to me by the companies. Why they wanted us to bring a solution to them is that they wanted to lower their carbon footprint in producing these cups. And then they changed to making the paper ones. And they realized that it's almost 10 times slower to make the paper ones. So they needed to buy 10 machines to replace 1 machine to make paper cups compared to plastic cups. And I would imagine that somebody has more knowledge of this than me, but that was the background. Then, okay, they didn't want to do that. Then the next option, as discussed, is the reusable plastic cup, which has some benefits. You can use it, maybe, in theory, infinite amount of times. It's going to look ugly quite fast. You don't want to use it infinite amount of time, and the washing is fairly carbon-intensive, energy-intensive process. So you get some benefits, but you lose something. Then is our solution. As a company, everything that we do, we use the same machinery as they use for plastics. So we created them the solution that they don't need to change their machinery. They don't need to change their thermoforming machinery. The process stays exactly the same. They just change the material. Of course, as there's the price in there, the material is a bit more expensive because it's a new one, but not that much that it would benefit them to buy totally new machines to change the paper cups, or to buy an injection molding machine to make thicker plastic cups and use even more plastic, which, in my opinion, doesn't make any sense. To conclude it a bit, there's the time and place for all this. We don't want to, example, be in an airplane that is made out of biodegradable materials. It doesn't make any sense. I want my plane to hold intact as long as possible. And then, of course, there's a place also for paper and pulp packaging. But then what we did in thermoforming side was to position ourselves in the middle, so you don't need to make the transformation from the plastics, the conventional plastics that are obviously extremely good in many cases. The problem is that what do you do after use? You don't need to go directly from there to the pulp and fiber-based packaging, which is a huge change for both the manufacturing side, the usage side. You have maybe some robotics that you cannot use anymore. You need to change the whole chain. And we wanted to position ourselves in the middle. You get the environmental benefits, not maybe all, but at least most of the benefits when you get what you get from the fiber-based packaging or thermoformed items. But then again, you get the formability and usability of the conventional plastics. Again, not all of them, obviously, but enough, most of them. But then, other thing, they wanted to change from the thermoformed cup to something else. And when we discussed about the chemical recycling, we are able, and we have piloted this already a few times, and now there's going to be a few other pilots in the fast food chains who want to use reusable cups. So why don't do that also with a better option? If we think about the LCA calculations that were made, the paper cup against the reusable plastic cup, does it make a difference if we can use the same plastic cup, but we can use a material that with recycled biopolymers can even have a negative carbon footprint from cradle to gate? It may make a difference, I don't know. But that's what we piloted last year in Slush with, together with Sulapac and Lassila Tikanoja, that we created the reusable cups made out of Sulapac material, which was the last year maybe biggest innovation that we did. The biodegradable, bio-based material, you can put it in the microwave, you can put it in the industrial dishwasher, but then again, if it ends up in nature, it degrades. They used the coffee cups in Slush. No, actually they used it first in Nordic Business Forum, and then Kampa collected it, they used it, washed it, put it back, and get it back to Slush to be used again. And then Lassila Tikanoja collecting it, and then we deliver it to chemical recycling facility and get recycled content to our next materials. So we can maybe do food service items, chemically recycle it, and make a channel. That may be even upcycling at that point. But with that, I presented you two options from single-use plastic cup, single-use plastic thermoformed item, to reusable one. We don't want to use more plastic to use reusable ones. Let's use biodegradable ones. Or if you don't want to change anything, well, at least change the material and use biodegradable material for the same exact cup. And with that, I welcome you to get the questions to me and then wait the discussion in the panel. Thanks.
Thank you, Joona. Maybe one question from the audience, and then we'll start the panel. I think everybody's excited for the panel. We can also save your questions for the panel discussion. I have a quick question. So I really liked your slide that showed the example of Slush and how you closed the loop in that case. How do you perceive the challenge of bringing this closed loop model to larger scale businesses and really scaling that up?
I think in Finland we're living a bit in the bubble, because if we go to mid-Europe, as Andre's lunch cup from Frankfurt showed, they already use these kind of reusable ones in France, in Germany, in many places, also in fast food restaurants. So it's already done. We're just a few years behind while we're in Finland.
So your product would have, you believe, already a very good value proposition, but it could be easily enter these existing closed loops somewhere else. Yes,
exactly. So the same company who is making now the plastic cups for, let's say, McDonald's in Frankfurt, the same company, they need to change the material. They can make the same exact cup from our material to the same exact use and just implement the same cycle of usage. But then again, when you don't want it anymore, of course you want to collect it separately or put it in the plastic recycling stream, and when there's enough volumes, it's extremely easy to separate it with an IR from the plastic waste stream.
Perfect, wonderful. Thank you so much, Joona.